So one of the impacts of climate change has been the decline in the Arctic sea ice. And so over a relatively short period of time, it's a fraction that's in square kilometers. But you can see that it's gone down tremendously. So you got to remember that the polar regions, north and south, are the drivers of our weather. So for eons, the cold parts of the north, sort of compete with the hot part in the middle. So that is our generator of weather for the entire planet. And so now we've got the northern part, the northern refrigerator is defrosting. And so that's having a big impact on our weather. All of the impacts we're still not sure of, but we do know there are impacts happening, and there has to be, simply because a big part of what drives our weather system is going through a fundamental change. This was shocking to me. This is just recently. So this is the Arctic ice extent, so the amount of ice in the middle of the coldest time of the year in the winter. And the blue line at the bottom is where it is. And the gray lines in the shaded area, that's where it's supposed to be. And the difference is in terms of area. So the Arctic ice in the middle of winter, where it's 24 hours of darkness, there's now far less ice in the winter than there used to be. So that means even when it's super cold and super dark, the Arctic isn't forming enough ice. And the difference there is the size of Alaska, California, and probably Washington State. That's how much ice is now missing in the wintertime, this year in particular. And I've asked scientists, what the hell's going on? Why this year? And they don't know. This year was, 2017 was a warm year, but wasn't the warmest year on record. It was like the third, I think it was, or second. But that didn't have the same effect on the ice the previous years. So not sure why we're losing so much ice in the winter now. So that's a new thing. And for Canada, well, maybe less so for here, this is affecting the jet stream. And so our weather now has gone really weird, where it could be snowing up to here in the morning, and then it rains that afternoon and washes away most of the snow, and then all freezes that same night. So we're getting these really wild temperature fluctuations. Siberia had that one just a week ago, probably due to this, although the scientists don't know, this is speculation. They had a 100-degree Fahrenheit switch in northern Siberia over a 3-day period. 100 degrees Fahrenheit. Yeah, so it went from what it's supposed to be like minus 50 Fahrenheit, because this is really far north and really cold area, to plus 10 or 6, or not plus 10, that's Celsius. I got to do the conversion to Fahrenheit, to like 50 degrees Fahrenheit in Siberia in the middle of winter, where it's also 24 hours of darkness. So, yeah, it's having some kind of effect. The cause and effect part from a science point of view isn't certainly established yet, but there's no question there's an effect going on. So that's the scientific consensus and has been for several years, and there's a number of other studies that have documented the same thing, so all the research shows this is what's going on. So who's responsible? Now, it used to be the US was the biggest, so the big red ball there, that's the US, and the big blue ball on the right-hand side is China. So it was the US was the biggest for most of the last 50 years. China in the last 3-4 years has taken over for the US. Partially US emissions, US carbon emissions have gone down. China's continued to go up. But if you had a little flag in every CO2 molecule in the atmosphere that humanity put up there, most of the flags would be waving the stars and stripes still. Because CO2 lasts forever. So when your car emits CO2, it's going to be in the atmosphere for hundreds of years. It doesn't go away. It stays there. So all of the CO2 that's come from the US in its 200 plus year history is still up there, and it will be up there for at least 300-400 years to come. So that's why acting on climate change now is very important, because once the stuff is up there, we don't know how to get it out yet. But I'll talk a little bit about solutions a little bit later. So you can see how things are changing. Asia now is becoming a bigger source of CO2. However, I'll say, just below the big ball is India, which is growing quite quickly. But they are also switching to alternative energy very fast as well. So there's some good news there. China also is cutting their coal consumption because air pollution is terrible there. And so they're finding other ways to generate energy. And so this is something that's not entirely doom and gloom. Now, generally speaking, those who contributed least to climate change are suffering the most and will suffer the most. So the small island states, where places where people have already been forced to move because of sea level rise, they've got practically no CO2 emissions. But everybody is being affected. Some much more than others, in part because poorer countries have a hard time coping with the changes from climate. And you can see in the future, the bottom part of the graph is about vulnerability, so who's most likely to be impacted, and part of it is a combination of how the climate's going to change and how they can handle those changes. How can they respond to the changes? In the US, you can build higher seawalls. In a place like Ghana, where the sea is rising, they can't afford to build seawalls. So how come everybody doesn't know about this stuff? So this is a little bit out of date now, but the chart of newspaper coverage. It hasn't improved much, I can say that. So one of my biggest challenges as a journalist is finding ways to get stories about climate change published. There's tons of research about it. Getting them published has been really difficult. Oh yeah, another climate change story. We're not interested. I mean, I've been to a lot of big meetings and come across a lot of scientists who have some breaking news, but I've been turned down more often than I've been had my stories accepted. And you saw that the big blip there was 2009. That was the climate change conference in Copenhagen. So that was the last time climate change got a huge blip. There'd be another blip. They haven't updated this chart yet for the most recent Paris climate change meeting, but it wasn't as big as the Copenhagen one, sadly. So that's one of the reasons why folks don't know about climate change. It's, some people, I've been writing about it for 20 years. Scientists have known about it for 30, 40 years. So there isn't that awareness. It isn't often not taught in schools. So the media is about the only way you're going to hear about it, or from people talking about it generally. You notice the blue line, which is North America, the coverage was less. So at a lot of these big climate meetings that I go to, most of the journalists aren't from North America. I'm usually the only Canadian, and there'll be like a handful of Americans. The rest will be people from Asia or other countries. So one reason there's a lot less climate denial in the rest of the world is because they do better coverage, the Europeans and even Africa. They do a better job. So that's something that is starting to change, has changed in the last few years, ever since the Paris thing. So Paris was the last big climate change meeting, although it's still, I think it's 2 years ago now, 2016. So 1.5 degrees was the decision. So in Paris, the world got together and said, all right, climate change really is serious, and maybe we're going to do something about it. And we're going to look at limiting the global temperature to 1.5, hopefully. Hopefully. We're already at 1 degree, so that's going to be extremely difficult. But the big thing about Paris was actually an agreement by all countries that we're going to phase out fossil fuels. It was absolutely the first time all the countries said, yes, we're going to get rid of fossil fuels. Their day is done. And that's significant because all of these meetings are consensus-based. So any of the official statements, everybody has to agree on. So 198 countries, including Saudi Arabia, whose entire economy is based on selling fossil fuels, they had to agree to that. It took 20 years to get to that statement. So it's been a very slow process, as you can see here from this graph of all the meetings. So after the Warsaw one on the far right, it was Paris, COP20. Now, I haven't been to all of those meetings. I do know people who have been to every single one of those. So that's hasn't had an effect on the actual amount of emissions yet. So we're in the awareness part. We're now maybe turned the corner on understanding that we need to act and act quickly. This is a story I did for National Geographic this summer. And we're also learning the damages. The costs of climate change, even in the US now, are in hundreds of billions of dollars. And they're only going to increase. Again, more energy in the climate system, more energy for storms. So hurricanes have become much more powerful. So the category 5, category 4 and 5 happen more often. And so this last summer was the most destructive year ever for the US in terms of hurricane damage. And the projections are, of course, it's going to increase. And this is not, US is just one example. The same kind of thing is happening in other places too. In the Philippines, they get hit by typhoons, which is another term for hurricane. So often now, their parts of the country are regressing. They're not progressing. They're going back, basically being typhoon bombed back into the Stone Age because they get storm after storm that destroys everything. And they can't afford to rebuild now in many parts of the country. So the impacts of climate change are becoming more obvious, becoming more expensive. But what hasn't really gotten through yet, I don't think, there's another story that I wrote, is that you can't solve a problem by making it worse. So that's the sort of point of this headline. You can't continue to build new things that use and burn CO2, because you're just making your problem worse. So in other words, in this sort of basic example, you can't keep building new coal plants. Because once a coal plant is built, you're not going to tear it down 5 years later. It's going to continue to operate for 20, 30, 40 years and all the emissions. So this is based on a study that looked at these, they call it emissions that we'd be committing to by building carbon infrastructure. So anything that burns carbon, even a new car, factored into this. So if you build, 100 million new cars in 2018, those cars are going to operate for 5 or 6, 7, 10 years, and they're going to emit carbon, CO2. So you got to account for that. So to stay below 2 degrees, that means we'd have to stop building cars that burn CO2 in 2018. So that's not going to happen. Because there's not much understanding of this particular scientific fact that if you build stuff that is going to burn CO2, it's not just the CO2 they're going to burn today, it's over their whole life, unless you're going to throw out hundreds of millions of cars or convert them somehow. And so by doing a bunch of calculations, they figured out that this would be sort of the year we'd have to cut it off. Otherwise, we'll be already committed to blowing our carbon budget and pushing ourselves beyond 2 degrees. It also has some financial implications, because if you decide in a panic that we need to avoid the 2 degree increase, then we'd have to trash all of this new carbon burning stuff to make it possible. This isn't very well known, unfortunately, so I've done like 3 versions of this story, because that study didn't get hardly any coverage. In part because it was kind of a little bit complicated, not that easy to explain. However, I think it's a pretty important thing to just keep in mind. So when it comes to making decisions about what we're going to do, what industries we're going to support, stuff we're going to make, how we're going to run our economy, it sort of makes the point that you have to take the carbon commitment that comes with these kinds of decisions seriously. So that's something that political leaders and business leaders need to understand. And some are getting this message, but it's coming slower. So we're still looking at a 3.5 to 4 degree Celsius increase on a basis business as usual, converting that into Fahrenheit, 6 to 7 degrees Fahrenheit increase. Now, the one thing to keep in mind that's a global temperature increase. That doesn't mean the temperatures here are going to go up that much. They could go up a lot more. For instance, the Arctic, the temperature increase is already 3 degrees higher than it was 100 years ago. So while the planet is only heated up warmer by 1 degree Celsius, it's 3 degrees Celsius warmer in the Arctic because the heat is uneven. So the Arctic is warming up way faster than everywhere else. Also, heat, again, being another form of energy, means we're going to have a lot more energy in the system if we get to 3.5 to 4 degrees Celsius. And that's the business as usual scenario that's the path we're on right now. Despite the efforts of those climate change talks to reduce emissions, the commitments, the Paris Accords, all that kind of stuff, we're still in that. We haven't done enough, and the promises and the commitments countries have made still does not get us into the safe zone. We've still got a long ways to go to cut emissions. All right, so we've got this new reality, the new climate reality. So part of what I'm hoping here is getting across the idea that things have to be a lot different than they are presently. The future is not going to be anything like the past. And we're going to have to imagine what that future looks like, how it can be different and better. And that's actually one of the biggest challenges we're having right now is this imagination. How can the world be different and better without using fossil fuels? It's kind of it sounds simple, but we are really having a hard time imagining how things could be different. So we end up in this thing of just doing incremental changes, like little tiny fixes. We'll increase the fuel economy of the car by 5 miles per gallon or something. Yeah, that's not going to do it. We need a fundamental shift and fundamental changes. We've delayed it too long, so we've got to make some major changes, but it's going to take a reimagining of how we live our lives. It doesn't necessarily mean hardship. It just means we have to think in new ways. It could be a lot better. The whole animal food industry, which has a huge climate footprint. Well, one of those reimaginations, which to you folks wouldn't be so difficult, but to many others, the idea that they would be vegetarian or vegan is beyond their comprehension. And yet, there are tons of people who have made the conversion and feel better, are healthier, live productive lives. There's professional athletes who've done the same thing and said it's really helped improve their athleticism. So, but those are kind of things that people need help imagining how the future and how things can be different. Planting trees. So I like this a cute cartoon that even a child can make a difference. Very often children are much more receptive to these messages of the need for changes. And they have an innate desire to want to protect the environment, to protect nature. Somehow they lose that as they go through years of school, probably. And yes, that's one way, planting trees, planting plants, generally. This is what's coming because there is a change in the wind. So we've gotten a lot more solar, a lot more wind. It's cheaper now. In India, it's actually cheaper. Solar is now cheaper than some of their coal plants, like building brand new solar. It's cheaper than operating their old coal plants because they were so inefficient. And so they're rapidly shifting to solar and wind in India, also in China, also in the US, also in Canada, pretty well everywhere in the world, because now it's one of the cheapest forms of energy. And becoming more and more practical. There's still some technical problems of grid and that kind of thing, but it's becoming cheaper and cheaper. And that's one projection from Bloomberg, which looks at this stuff. And more money is being invested now in green energy than in black energy. It needs to happen faster and faster. It needs to ramp up. It can't be simply a little bit at a time. Hopefully that's going to happen. Yeah, so on a more practical level, somebody mentioned Elon Musk the other day. And yeah, he kind of changed the thinking about electric cars by producing a super nice, super sexy, fast electric vehicle that was practical because it had a decent range. Yeah, it was ridiculously expensive, but he proved it could be done, and then has now launched his more affordable version. And so that's shifted the entire industry. You keep in mind that when Musk introduced his cheaper Model 3 car 2 years ago, I guess, they had 500,000 orders, like within a month, for a car that didn't exist yet. A car nobody'd seen other than in this little video presentation, and that he told people would be 18 months before you could even get one. And so 500,000 people put down a $1,000 deposit on top of that. I mean, that is something that shook up the car industry like nothing else in the last decade, last century, I think. Because some of the big car companies, they don't sell 500,000 cars a year. And here was people buying cars that didn't exist yet from a company that was tiny and could go out of business at any time, and they would be patiently waiting for 18 months. So that changed, and so as a result, now all the car companies want to build electric cars. Turns out it's not that hard. Turns out electric cars are far more efficient than fossil fuel cars, just from an energy point of view. Their engines work much more efficiently. And they are easier to make because they have way fewer parts. So manufacturing electric cars is actually going to be cheaper once there's enough volume. And that's coming close now. So they're easier to make, they're cheaper to make. The battery costs have gone way down and continue to go down. It won't be too long before electric cars will be cheaper than a fossil fuel car. And they'll have comparable ranges, whatever, 400, 500 miles. Maybe not, yeah, around there. And the charging infrastructure, one of the things that this article is all about, the transition from horses to Model Ts. So, how long did it take to go from everybody riding around on horses with New York worrying about all the manure piling up in the streets to there not being any horses at all? It was like within 15 years. We went from everybody on a horse to everybody in a Model T. It happened really fast. And it was a bigger transition because horses didn't need paved roads. Cars did. And so the roads had to be paved. Gasoline stations had to be built. The oil industry was just getting started. They had to start making oil. So there was far more hurdles in that transition to the Model T than the one we're facing to go to electric vehicles. Now, electric vehicles aren't the answer for everything. We still need good transit. So electric trains would be nice. I mean, I enjoyed the New Jersey train from the airport into Penn Station. It's just like traveling in Europe, which is all electric trains. And their trains go really fast in Europe, like 200 miles an hour. So most times you don't need to fly anywhere. You could just take a train. And they're super comfortable, and you don't have to go through the same kind of security nonsense. It's a much more civilized way to travel. Hopefully, and that can happen here too. So, I think that's my last slide, because I'm filling in for somebody today. Climate change is a threat to humanity in many, many respects. It's mostly a threat to our way of living, our current economy, which needs to shift to a more energy efficient economy. But we also have to change a lot of our behaviors and habits, food being one of them. And we need to get on this right away because the physics of climate is not going to wait for anybody. To tell you a short little anecdote. So at the Copenhagen climate change meeting in 2009, I met the chief science advisor to the German government. Angela Merkel is the, chancellor, I guess, so like the president. And she's a physicist, actually, so, one of the few leaders who's actually science trained. But she had a science advisor who's a specialist in climate change. And she lent him to the Obama administration during the Copenhagen talks to sort of say, okay, well, you don't have to believe your own scientists. How about this German scientist? And so they talked about it. And this German scientist said to me he was stunned at the reception. They understood what he was talking about. They accepted climate change and all the rest of it. But they said, you got to give us a politically realistic solution to acting on climate. And he was kind of stumped on that one. He said, well, I just explained the physics of climate doesn't care what people think. It just does its thing. You can't negotiate it with it. You can't bargain with it. It's just going to do what it's going to do if we keep putting emissions out. So the only way to do anything about it is to stop putting emissions. And we have to do it at this rate in order to avoid these really bad consequences. And they said, well, yeah, but we need a politically realistic solution here. He said, there isn't one. There's just plain physics of CO2, heat, bad things happen. The only solution is to cut the amount of CO2 down. So he was stumped that these guys kept saying you had to have a politically realistic solution. And, in truth, that is one of the biggest dilemmas that we face, is solutions that are politically realistic. So the electric vehicle thing, that's now become a politically realistic. So governments could support that effort. So Norway, for instance, almost all their new car sales are electric vehicles. Now, Norway is a really cold country, so actually the batteries don't work as good in the cold. But they work fine, you just don't get as much range. But the reason why so many electric vehicles in Norway, and they hope to have 100% of their vehicles in, I think, 5 years now, is government support. So electric vehicles can park for free everywhere, they get special tax discount, they get this, they get free electricity charging, they get a lot of benefits to go with it. Their electric cars are cheaper to buy in Norway than a fossil fuel car because there's hardly any tax on them. So governments can do a lot to make this happen, and Norway's decided, yeah, we're going to be the first country to be 100% electric vehicle. That was politically realistic, and it's a conservative government. It's not like a progressive green government. It's actually a very conservative government. So that's going to reduce their emissions a whole bunch, and turns out people really like driving electric vehicles because they're super quiet. They go like heck, and it's just much more pleasant to driving them. So governments can play a role here, politically realistic, solar panels. These things are happening because government can make things happen a lot faster, and that is starting to happen. Companies as well, as companies decide they're not going to be, and recently some of the big fossil fuel companies have said, oh, well, we're going to get to wind and solar too, we're buying wind and solar. I think the British Petroleum, BP, no, not BP, but some of the big companies are actually now putting electric charging stations in their gas stations and letting people charge for free. Eventually, of course, they'll charge, but so things are moving along, and that's the kind of politically realistic things that can happen, but we need to push that envelope of what's politically realistic because, like I said, the physics doesn't care about our politics. It only responds to changes in the atmosphere, and those changes are not going to be good for us, and they're going to be super expensive. So let's all try and do what we can to reduce our own emissions and push our leaders to do the same. Thank you.